Bismillahirrahmanirrahim. Assalamu alaikum everyone and welcome to my channel. So in this video we would be studying about timers encounters and how they're working and how to use TCNT timers with LCD. So first of all, the first task is to display counting of TCNT resistors on LCD and also counting how many times the TCN counter is overflowing and showing it on the LCD. So first of all, you need the LCD header file. I would be explaining it in my preceding task because I have already made a detailed video about it in my previous video of lab 5. So in this lab 6, I would be first certainly concentrating on timers encounters and first of all, there are many types of timers encounters, and they're different. Their application in AVR and FL Studio is really vast. So first of all, in this code, we would be first declaring port B and port C as output, as we have declared 0 cross FF, port B DDRB 0 cross FF, and 0 DDRC also 0 cross FF. And then I'm so sorry, it should have. I'm sorry for that. Then we have created a character array of 11. You can create it about whatever size you have and whatever you needed the most. So why I've created this character array, I would be explaining it afterwards as well. So first of all, LCD init, this is due to the header file of an LCD. This is initializing the means opening of the LCD. And then we have declared LCD string counter is equals to. So this was LCD string, and this is the what would be displayed. This is as it is counting, so that's why we have displayed as the counter. So the TCNT 0 is taken as 0 0. So first of all, the TCNT 0 flag is off, and then we what we have do and that we have stored T0 value in TCC is R0A, and then we have stored 0 1 in TCCR0B value. Then what we would be doing, that we would be implementing that DIF R0 flag and it comparing it with if is on, then TOV 0 flag is on. Then what would happen, then that the TCNT 0 array, that from the array it would take one letter, that my maximum range was at 11. Your maximum range could be proceeding to as much as you want, and then a 10, and then the string array. But then LCD, whatever the letter that would be implemented over there would in the array in the starting one, it could be implemented in the string as well, to the string as well. The LCD MS 050 and then the preceding value would be implemented. Now, the delay of 500 milliseconds is given in the command, means it would be declared at the output, and then TCR0B is the at the end of the code is turned low, it says turned low, and TIF RO0 0 flag is also turned low with TV 0. So I will be showing, let's see this hardware function. Now it will be proceeding to its hardware function, and I'll be showing you is. So this was it. So what we were doing, you would be simply implementing it. Okay, so there is one mistake in my one. I have not corrected the pin configuration according to it. So I would be now explaining you how we would set the pin configuration as well. So 1 minute. Okay, all set. Now we would go hardware PB0. So in this one it's PB0. But my one was PA. If I convert this into A, that there wouldn't be any kind of difference. Then I have to just change it over here as well as A. A. I would be converting it into 2 and R A3. So what would I would be doing? I would be doing the same thing over here with my LCD as well. RA23. So first of all, I would be saying RA23. No, 24. Let's see if this was it. Yep. No, sorry. It was P. RS is 1. So RS is 1. So it would be 22. Let's check it out now. It's still some issue it's given. Okay, I again selected the next. Um, wrong one. Okay, I hadn't like. So let's see. Yeah, over here it is giving. It is counting like 160. It is count to 60. It is count. It would be counting, and then seeing it how it is working. It is very fast because my today is very small, so that's why it is showing the result. You can also see them with the second one. Now the next one function, in the next one function we had to create a digital watch, and in the digital watch we first string, we implement the string that minutes seconds and hours, and then we get the for loop for minutes 60, then seconds for 60 as well. I've created this a function in it for hours. That would be for range of capacity. Then the TCNT delay function is added. TCNT is basically used for the delay function. So in this, I need 1 second for delay, LMS delay, LMS delay. So it would be TCNT one. A higher bit is LMS, and DCNT a 1L bit lower bit is then 80. So the TCCR 1A is 00, that is normal mode, and TCCR 1B, that is one that it means no prescaler is added. And then while TIF R1 is on and while the loop is this, we have considered the while loop. You can also write this with a for loop as well. Then the TCCRB1 R1B is 00, that means it's timer, and TIFR 1 is clear, that is flag registers. So this was it. So let's see with this one how it works. Um, we would simply be going to uploading the code and then seeing it over there. Then I'll also be showing you the hardware of all of these functions. Um, I have to go away again. Sorry for these delays. Uh, so here is my digital clock. It's working. It is literally counting time like all the with seconds 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it will be going on further ahead. Now, after this, the last task was this. And this, what we have to do is that we have to control it by switches. Now, if by switches, what we would be doing is, okay, this was the header file. This is a, so in this, we would be, okay, I'll be showing what we would be doing. So, the first one was this, second one, and third one is that we count an external event by using switches, by using like we on and off it by using switches. A switch would be added and off, and turn on and off. So let's see for the starting ones. First, they declared DDRD is and is equals to 1 6 1 6. That means it means that not without it's 6 bit, else and it's 6 bits are converted into input. And then what we have done is that DDRC, that is port DC, is converted with the is our output port, and the port B is converted into output port. Then TCCR1 A is equal to 0. This means that it is a normal mode, and TCCR1 B is equal to 0 plus 0. This means the falling edge. So OCR 1A is equals to 1. This means CTC mode is enabled, and then int constant is equals to 0. Then we create an array is equal that has 10 elements, and then LCD initialized, and this means LCD is turned on. Then LCD command is enabled, and then the LCD string of counting is carried on. Then what will happen? We create a while loop in which we first turn on the OC F1A flag on, and then what we would do, we would then declare turn it off. And constant is equals to constant plus 1. This means that whatever the value that would then see the constant value would be, that we start from 0, it would be added from 1. 1 would be added into it. And the constant and array and 10, then this would be implemented in the array. So let's see, it's hardware over here. So we simply stop this code and we implemented the next code that would be of our timer counters one, the third one. We simply go to the code where we saved it. And we play the counting. So this would be counting if I just press it 2 times. Okay, I forgot to add a switch in it, but it would be working with a switch. So as soon as I press the switch 2 times, it would be counting it. As right now I've not included a switch in it, I simply go, although I had a PCB for it, so I'll just simply go there. Oh, sorry. Sorry for the inconvenience. So let's just simply add a switch over here. We have a button. Button. Oh, that's so weird. So I will be showing you the video simply, and that would be explaining it. So this would be the video. I have done my synchronization over here. Okay, I added the switch incorrectly. I'll be showing you that how it is. So you can see over here, the first it is a 0, then this is the hardware of it. And then after that, I would be pressing it the switch once, and then it would be counting. The switch is turned on and off, and you can see that it is counting over there. So this was our digital clock that I had shown you. This was its software that I had already shown you, and this is its hardware. You can see it is counting it absolutely correctly. And this was our LCD TCNT timer. So you can also see that it was counting over here as well. So now let's see it's on the house, the LCD, and you can see it is counting over there as well. So it is absolutely correct. I hope you understood. Thank you very much. Jazakallah.